A weight of 1,000 pounds is suspended from two cables as shown in the figure. What are the tensions in the two cables? What we're going to do here is draw a force diagram representing the situation. We need to understand that when an object is in static equilibrium, the sum of the forces acting upon the object has got to equal 0. So, to draw our force diagram, I'm going to draw a dashed line like so to represent a point of reference. This horizontal dashed line represents horizontal movement, and the vertical dashed line represents vertical movement. For example, we have a force acting straight down, which represents the weight of the box. Let's call this force 3. Force 3 is going to equal negative 1,000 J. We also have the cable that's pulling in this direction. Let's call that force 1. We know that the angle between the horizontal axis and force 1 is 40 degrees. We have a cable that's also acting in this direction. This angle right here is 25 degrees, so the angle between the positive x-axis and the force, which is the cable, is 155 degrees. Let's call this force 2. So, what we want to do is express force 1 in terms of its I and J components. That's going to be the magnitude of force 1 times the cosine of 40 degrees in the I direction plus the sine of 40 degrees in the J direction. Force 2 is going to be the magnitude of force 2 times the cosine of 155 degrees in the I direction plus the sine of 155 degrees in the J direction. And finally, force 3 is going to be negative 1,000 J, because it's acting straight down in the J direction. Now what we'll do is recognize that the sum of these three forces must equal 0. That means that the sum of the forces in the I direction must be 0, and the sum of the forces in the J direction must also be 0. We can express that as follows. The magnitude of force 1 times the cosine of 40 degrees plus the magnitude of force 2 times the cosine of 155 degrees must equal 0. In addition, the magnitude of force 1 times the sine of 40 degrees plus the magnitude of force 2 times the sine of 155 degrees plus negative 1,000 must also equal 0. So what I have here is a system of two equations containing two unknowns. What I'm going to do is solve this system using substitution. I'm going to take this first equation and solve it for F1. So the magnitude of F1 would equal the negative magnitude of F2 times the cosine of 155 degrees divided by the cosine of 40 degrees. Now, wherever I see a magnitude of F1 in the second equation, I can put this expression in its place. What I get is negative magnitude of F2 times cosine of 155 degrees divided by cosine of 45 degrees. That's the magnitude of F1 times the sine, this should be 40 degrees, times the sine of 40 degrees, then plus magnitude of F2 sine 155 degrees minus 1,000 equals 0. So this is the equation that I need to solve for the magnitude of F2. The way I'm going to do that is factor out magnitude of F2, and then I have cosine of 155 degrees divided by cosine of 40 degrees times the sine of 40 degrees plus, there should be a negative here, plus sine of 155 degrees, and that equals 1,000. I divide through by this, and I get the magnitude of F2 is going to equal 1,000 divided by negative cosine 155 degrees over the cosine of 40 degrees times the sine of 40 degrees plus the sine of 155 degrees. If we work this all out, we get that the magnitude of F2 is about 845.2 pounds. So that is the tension in the second cable. Now we can find the magnitude of F1 by substituting the magnitude of F2 into this expression. If we do that, we get that the magnitude of F1 is 1,000 pounds.